Hi, this is a video about multiprotic acids and strength of acids, just an introduction to strength. So the first thing I want you to know, and I think you're probably aware of, is that acids can be either monoprotic, like down here, for example, HCl, hydrochloric acid, that's found in our stomach. This is acetic acid that's found in vinegar. Here is nitric acid. Those all have just one proton or one hydrogen, so they're called monoprotic. Multiprotic are going to either be di or triprotic. Diprotic is like di, the prefix means two. So for example, sulfuric acid, that's found in our car batteries. A triprotic acid could be, this would be phosphoric acid, so 3 protons or 3 hydrogens. So the question is the strength of an acid, we're just starting now to talk about strength, like would we expect the phosphoric acid to be stronger than the hydrochloric acid? And the answer is no. So what we have to do is think back to electrolytes and the tendency to dissociate. So an acid, when it is strong, is going to break apart or dissociate, ionize completely into ions, and you're going to get a very positive conductivity test. And then if it's a weak acid, it has to have some ionization, give off that hydrogen ion, otherwise it wouldn't be an acid. But if it's weak, then a weak acid is going to not give too many ions and then therefore be a weak electrolyte. So I have a little video clip. Normally I would do this with you. It makes me miss you. So here it is.
Okay, what you're looking at is a conductivity tester, which is...
Try to make him bigger.
Which is just a light bulb and some electrodes down... Which is just a light bulb and some electrodes down below.
Just like
when I touch the electrodes with this cupola, which is made of metal,
kind of a pyro.
Okay,
He's got
I'm just
insulated
completing
end
a
that,
connection
so it's okay,
for the electrical circuit.
Here, well, let's
I have
start
a beaker
here.
here with hydrochloric acid in
Hydrochloric
it.
acid.
And what is your prediction? Is hydrochloric strong or weak? Strong. Which means it ionizes how much? 100%. Okay. Now, I'm just going to barely touch the water to the electrodes. Just a little bit. It's pretty hard to not have it conduct and get as bright as that baby will go. Notice it does dim down a little bit as I get more shallow. I'm just letting it down, barely touching. Got lots of conduction, which means, what does that mean when it's conducting a lot? What's helping it to conduct? Ions. Okay, here we go. What's my next stuff to test?
Acid.
What is it?
Oh, acetic acid.
Acetic acid. Okay, is acetic acid strong or weak?
Weak.
Weak, okay. What is your expectation?
Low light.
Low light. Oh, low light. Let's see. Low life. Not low life, low light. Now you see it's just barely coming on, and as I get it deeper in the water, you can see that's about as much as I'm going to get. Okay? What does that mean about the number of ions in the water?
Very few.
A bunch less. Yes, a bunch less. Yeah.
All right. Makes me miss you guys because I love doing demos with you. So that is just kind of showing you just an introduction to why a certain acid would be considered strong or weak in terms of conductivity and ionization. So here is a picture. It's in your textbook on page 486. But you can see what it's representing here. The green are the chlorine atoms. The red is oxygen. The blue is hydrogen. So these are all oxyacids. So they're acids that contain a polyatomic ion that has oxygen. So we would normally write this as HClO. We would write this as HClO2. But the structure, they draw out this because that's the way it is actually in the Lewis structure. So you can see that as we go across, we are getting a stronger acid according to the diagram. So the bond, if you think about what an acid has to release that hydrogen or proton. So it has to give this blue proton away. So as we go to the right, it has to break this bond. And the bond is, let me show you with my marker. It's in the Lewis structure. It's right here. You know, we would probably draw it as OH. So that has to be broken for this guy to go away and be on his own, like he's going off to college or something. But anyway, so the more likely it is to break that bond and release that hydrogen ion, the stronger the acid. So you can see that as we have more oxygens, it's more likely and easier to take that proton off. So the question is, why? So I want to just review with you what electron density is. So remember that when we have polar bonds, that if you have an atom that pulls on the electrons more so than the other, then we draw that dipole in, or we at least think about it. Like oxygen and hydrogen, that bond between them, it's not shared equally. The oxygen is going to pull those electrons towards itself because it's very electronegative. So there's going to be more electrons or more density of electrons on the oxygen end. So then what I did is I found these are density diagrams of those 4 acid molecules. So this is the H hypochlorous. I have to think about my naming system. This is chlorus. And then this was chloric acid, and then HClO4, perchloric acid. So if you look at the key down here, the red in the diagram is representing a higher density or more electrons, and then the blue, the darker the blue, the less electron density. So you can see, the darker the blue, did I say that? I don't know. So look at the blue color change. As I add more oxygens, the blue gets darker and darker because you just keep adding more of those really electronegative oxygens. So easier to pull this guy off, and then he gets to go and be by himself, and than it is to pull this guy off. But they all have to come off to some extent, otherwise they wouldn't be considered an acid. I hope that helps you understand multiprotic acids versus monoprotic, and then why oxyacids get stronger the more oxygens are in the polyatomic ion.